On the morning of 3 June 2026, Iranian Shahed 136 kamikaze drone executed a precision strike on Terminal 1 of Kuwait International Airport. Kuwaiti military personnel recovered the intact MD-550 four-cylinder air-cooled piston engine from the impact debris, confirming the platform as a standard Iranian loitering munition. The attack followed an earlier strike on regional fuel storage infrastructure, yet demonstrated the Shahed 136's capacity to reach civilian targets at strategic depth. This analysis details the scientific principles of piston propulsion, inertial GPS guidance, low-altitude aerodynamics, and radar-evading kinematics that enabled the drone to cover the launch-to-impact distance from southern Iran and deliver its warhead directly into the passenger terminal. The Shahed 136 employs an MD-550 engine producing approximately 50 horsepower at 6,500 RPM, driving a two-bladed fixed-pitch propeller. The power plant integrates a four-stroke inline-four configuration with finned cylinder heads for passive air cooling, delivering a cruise speed of 150 to 180 km per hour while consuming roughly 12 liters of gasoline per hour from internal fuel bladders. At a typical mission cruise of 160 km per hour, the drone achieves an endurance exceeding 10 hours and a maximum range above 2,000 km. Operators launched the platform from a mobile ground launcher in southern Iran, approximately 551 km from Kuwait International Airport coordinates at Lamerd Airfield Reference Point. Flight time calculation follows basic kinematics. Distance divided by constant velocity yields 551 kilometers divided by 160 kilometers per hour equals 3.44 hours, or roughly 3 hours and 26 minutes of continuous autonomous flight. The drone maintained a low-altitude profile between 50 and 200 meters above ground level throughout the ingress, minimizing radar cross-section through nap-of-the-earth terrain masking over the Persian Gulf and Kuwaiti desert. Composite airframe materials and faceted surfaces further reduce the radar signature to below 0.1 square meters in X-band frequencies. Guidance architecture fuses strapped-down inertial measurement unit data with commercial-grade GPS corrections relayed through Iranian satellite augmentation or regional ground beacons. The onboard flight computer executes proportional navigation, augmented by terrain contour matching, stored in a digital elevation database, updating position every 0.1 seconds to achieve circular error probable under 10 meters at terminal phase. Real-time heading corrections compensate for wind drift using pitot static air data and magnetometer inputs, while the autopilot holds constant altitude via barometric and radar altimeter fusion. The 40-kilogram high-explosive warhead detonates on contact through a piezoelectric impact fuse, releasing energy equivalent to 20 kilograms of TNT. Blast wave propagation follows the Hopkinson-Kranz scale distance law, generating peak overpressure exceeding 100 kilopascals at 5 meters and producing structural fragmentation of the terminal's reinforced concrete roof and glazing systems. Thermal footage from surveillance cameras captured the millisecond-scale flash, followed by sustained secondary fires from ignited aviation fuel vapors and electrical cabling within the passenger hall. Kuwait's layered air defense network, incorporating Patriot PAC-3 batteries, short-range surface-to-air missiles, and ground-based radar, intercepted the majority of the inbound salvo. The Shahed 136's slow speed and low altitude trajectory nevertheless permitted at least one platform to penetrate the terminal engagement zone. Post-impact recovery teams documented the MD-550 engine wreckage still attached to its composite firewall and propeller hub, with cooling fins intact and crankcase showing characteristic piston scoring from sustained high RPM operation. Metallurgical analysis of the debris confirms Iranian-manufactured components consistent with serial production Shahed 136 airframes. Launch distance of 551 kilometers from southern Iranian territory remains well inside the platform's published performance envelope, while the 3-hour 26-minute flight duration allows operators to maintain launch site safety and execute time-on-target coordination with other assets. The recovered engine debris provides direct forensic evidence of the platform's origin and operational parameters. Engineers continue to refine Shahed 136 variants through iterative improvements in engine-specific fuel consumption, composite airframe weight reduction, and software-defined guidance algorithms that incorporate real-time electronic support measures for threat avoidance. The Kuwait Airport strike illustrates how these matured technical elements convert a modest piston-powered airframe into a strategic delivery system capable of projecting effects against high-value civilian infrastructure at extended range. The mission succeeded because the drone's lower observable profile and autonomous navigation loop maintained command authority from launch through terminal impact. Centralized Iranian control nodes allocated dedicated GPS augmentation channels and pre-programmed waypoints that bypassed traditional radar horizons.